I said the independent is depth, and the dependent is temperature.
Okay.
And the temperature starts somewhere in the positives and lowers down to 0.
Okay. Close. It starts in the positives of 0, but did you say anything about depth anywhere in your description? Okay, so let's include that, and then you're going to have it. Okay, can someone else want to give it a try?
Oh.
Okay, Sam, what you got?
As the water gets deeper, the temperature will decrease. It decreases to 0 degrees. It starts at a positive amount.
That would have been perfect. Okay, so a couple things he included there. Now, he actually just kind of talked about the line first, which is fine. So he says, as the temperature's dropping, what's going up with our depth? Okay, so the deeper we get, right? Isn't our depth, if I think about this, like 1, 2, 3, 4, 5, 6, the deeper we get, our temperature comes down. That should make sense. If you think about going into the water, when you go down the water, doesn't it get colder the deeper and deeper you go? Okay, so the deeper you get, the colder it gets. Okay, so you need to say something about that. So did you talk about that? The deeper you go, the colder it goes. If not, do that. Or talk about the temperature decreasing. Okay, so that was one point. Okay, start point. What do we know? Sam just says we start at a positive temperature. I agree. We can't say anything else. Okay, we're starting at a positive temperature. Okay, what's your depth at this positive temperature here, though? Well, according to this, it would be 0, right? Would we get 0? So would this be like 0.50 or whatever? Okay, so then we start diving. We get deeper and deeper, colder and colder, until what happens? Well, we've hit not necessarily the bottom. If we look at our temperature, what happened here?
It's 0 degrees.
0 degrees, and do we know how deep we are?
No.
No, so I mean we might be 100, 200, 300 feet down, we don't know. Meters, could be anything, okay? But as we came down, the temperature hit 0, and we're at some positive depth we don't know. Okay, so there's 3 things I was looking for. Start point, positive number, talking about it gets colder as you go deeper, and then talking about that once you hit 0 degrees, you're at some point of positive depth. Okay, talk about the endpoint. Okay, so if you can do that, make sure you write that stuff in there, correct your stuff. Okay, so 3 things I was looking for to get full credit there, including the independent dependent. Okay, all right. So on the next page here, number 7, okay, it says sketch a graph to represent the following situations. Identify independent dependent variables, label the axis, and give your graph a title. All right, so on A, we'll kind of walk through one together here. The height of a baseball after it is hit. So let's just start with a quick sketch. What do you think that would look like? The height of a baseball after it is hit. Okay? What do you think?
Height would be the dependent, and like the distance. Wait,
So he wants to figure out about height there.
yeah.
Okay, what else? What do you think is going to be on that x-axis?
Distance.
Does it say anything about distance in our problem? Don't add stuff in. So what's the other one? Guys, what's the x on going to be?
Time.
Almost always. Not every single time, but like 90%. You can't hardly go wrong there. Alright, more often than not, you're going to get that right if you just put time. Okay, so time and height. Now, what's a picture? What do you think a picture here is going to look like?
Oh.
Okay, Sam?
I don't think it's gonna start at 0 because it's not gonna be on the ground, so it's gonna be a little bit up
Okay.
on the graph, and then so it's gonna go up, and then it's gonna fall. It's gonna decrease to 0 at a certain amount of time.
Okay, so something like that? Okay. I like what he was saying. He said we're not playing golf, basically, right? We're going to hit the ball. If the ball's being thrown to a pitch to us, we're going to hit it somewhere in the air, so we don't want to start it at 0. Okay, all we know is the ball comes up, it's going to come back down. That's just kind of a given with baseball, throwing anything, right? Okay, and then it doesn't actually say it's going to hit the ground here.
Just gonna someone's gonna catch it.
Yeah, we don't know if someone catches it or if it's going to hit the ground. So in this case, you could argue either way. You could argue an end spot right here, or you could say, you know what, my ball got hit and I'm out. And you could put an end spot higher because they don't give you that information, okay? So either way, if you would have given me like an end point above or it actually hitting the ground, I would have counted it right because it doesn't say what happens when it doesn't get caught, does it hit the ground, we don't know, okay? Now, what would be a title here?
Distance of a ball.
Yeah, or you just put baseball, hit. You could put hit, I mean, it could be anything, okay? As long as it applies to the problem, all right? Now, he already kind of addressed this. We've already labeled our axis, give it a title, independent and dependent. Ben already kind of said that the temperature was our, or sorry, time, sorry, was our independent, and this was our dependent, okay? Alright, I'm gonna give you a second, I want you to try B on your own, alright? Sketch out what you think B will look like, it's your last problem.